Now, most of these quantities here are changing. The density of the shell is changing, the velocity of the shell is changing, and the radius of the shell is changing. Now, since the radius of each shell changes with time, it is convenient to define a reference radius against which to measure the expansion. That is going to lead to the definition of the scale factor. We can write the radius as a function of time as something that does not change in time and something that changes in time. So r is the radius of the shell. We call it the coordinate distance. Omega does not change with a particular shell. It is not a function of time. It is called the co-moving coordinate. It effectively labels a shell and follows its expansion. Each shell has its own value of co-moving coordinate. And A is dimensionless and is called the scale factor. So omega carries a dimension and is not changing in time. A is dimensionless and is changing in time. So the idea is that each shell has its own value of the co-moving coordinate and is the scale factor of the universe that is changing. It's called the scale factor because it is the scale that we have to multiply the co-moving coordinate to get to the coordinate distance. Now, by convention, at present time, the scale factor is 1. So by definition, at present, the coordinate distance and the co-moving coordinate are the same. This is important because what we want to know is how to calculate the scale factor at different ages in the universe.